Hello everyone and welcome to the channel. In this episode, I'll quickly go over the goals for this new series, building an 8-bit hexadecimal display, and then we'll move on to the first installment of the series. So I hope you enjoy. Okay, so over the past few weeks, I've been designing these 7-segment modules that are hexadecimal display, meaning they can display an 8-bit binary number using 2 characters. And so you can display numbers from 0 to 255. So I'm pretty happy with this design. The module is pretty compact. The electronics fit under the display, and it's really nice to use on a breadboard. And so I thought I would do a new series showing, how these work, how you can design a similar module on your own, and then go through various stages of sophistication on this module. The use case is being able to display 8-bit quantities in homebrew computers. And so, for example, this is my homebrew computer project, where I'm currently using 8-bit LED bars to display the address bus and the data bus. And it would be nice to replace these with these new display modules so that it's easier to understand what's going on with the CPU. And so this is what it could look like with these new display modules. As you can see, it's much easier to read and understand what's going on with the CPU when you can read the numbers rather than read in binary. So let's go over the plan for the series. So the plan for this series is to learn about 7-segment displays and design a compact module for breadboard use. I'll probably do a new design. I'm not going to reuse the first revision I already shown you in the video. We'll probably try to make it even more compact, but we'll see. In doing that, we'll try various techniques for decoding 8-bit binary numbers. We'll start by building a decimal display using a commercially available decimal decoder, the 74LS47. Then we'll move on to a vintage, not in production anymore, hexadecimal decoder to display the full range of 8-bit numbers. That's going to be the Motorola MC14495. Then we'll try to use a programmable logic device, the ATF16V8, to reproduce the functionality of the MC14495 with a modern chip. And then we'll work towards designing the module. So we'll move to an Atmega MCU, which is the one you can find in most Arduino boards. And we'll do a custom Arduino circuit on the breadboard. And finally, we'll miniaturize this circuit. We'll talk about PCB design and routing, and we'll do production of the final module. And I expect this series to be between 5 and 10 episodes total, but we'll see how it goes. So I hope you'll enjoy this new series. Let me know in the comments if there's anything you want to see, or if you have any questions or feedback. And I hope to see you in the first episode. Goodbye.